attend the awards ceremony at the Parliament of New South Wales on Thursday, the 22nd of October 2020. If the function is cancelled due to social distancing restrictions, finalists and winners will be honoured at the 2021 function. So please think about nominating a team member or emerging professional that shows outstanding potential. CIBSE accredited CPD providers offer a range of specialised technical sessions delivered across the region. These sessions are free to book and allow participants to hone their skills on a particular technology or process. CIBSE CPD certificates are issued for all attendees. CIBSE will be hosting an accredited lunchtime webinar on thermal energy metering technology on Wednesday, the 13th of May 2020. Please register for this at cibse.org.au. ARBS Exhibitions has announced that ARBS 2020 has been rescheduled to the 15th to the 17th of February 2021 at the Melbourne Convention and Exhibition Centre. It is Australia's biggest HVAC&R event that will showcase hundreds of new products and technologies which are set to shape the future, with a focus on emerging trends and technology in the areas of smart Internet of Things solutions, automation and control, refrigerants, energy efficiency, plus much more. Over 3 huge days, visitors can connect with manufacturers and distributors to see the latest products and applications, whilst exploring leading design and innovation in HVAC&R. You can visit CIBSE on stand 82. Just some housekeeping items to bear in mind. We will be hosting a Q&A session at the end of the presentation, and please use the Q&A buttons on your Zoom facility to log your questions. There are a few settings you can adjust during the presentation, particularly view in the top corner of the display. Also, the panellists will be displayed down the right-hand side, I believe. We are also endeavouring to make a recording of the webinar available after the event. So our presenter tonight is Dr. Jane Lai, and she's the Sustainability Manager ERBIS, which specialises in building services. She holds responsibility in sustainability reporting, energy performance analysis, and building design and documentation. Jane is a chartered professional engineer, WELL accredited professional, Green Star accredited professional, and NABERS accredited assessor. She has worked across new and existing assets, including commercial and residential buildings, retail shopping centres, hotels, defence, and aged care buildings. Jane completed a PhD in risk appraisal of infrastructure projects at the University of Melbourne. And Jane's presentation tonight aims to provide an overview of sustainability concepts currently employed in the building construction industry, with a focus on energy performance. There will be a discussion on energy efficiency design and its operational implications. Tools, guidelines and standards that are extensively used will be explored, including NCC Section J, Green Star and NABERS. Welcome, Jane.
Thanks, Tony, for the kind introduction. Just making sure that the audio is on. Yep. Thanks, CIBSE, for inviting me the opportunity to speak tonight. I'm very excited to talk to everyone about energy performance in the Australian industry. Yeah, it's unfortunate that we have to do the presentation over a webinar. I'd love to have met a lot of you in person, but we'll make do with this, and I'm sure we'll have a good time tonight. So my name is Jane, as Tony mentioned. I'm the Sustainability Manager at ERBIS, which is a building services engineering firm, consultancy firm. We do a lot of projects in all sorts of sectors, so commercial, hotels, residential, fit outs, community buildings, and the sort. So I head up the sustainability team at ERBIS, and I do a lot of energy performance analysis. We do a lot of Section J's and JP3s, sustainable management plans, NABERS, Green Star, WELL, and so on and so forth. So what I'll do tonight is have a discussion on sustainability as a whole in industry, and then with a sort of a focus on energy, which I'll talk about through in the lens of the National Construction Code, Green Star, which is sort of had the start of the design process and considering energy efficiency in buildings. And then I'll move on to the operations and how that's assessed after it's been built. So that's usually through the tools of NABERS. And then after that, I'll sort of discuss where energy is important in terms of some other tools that we use. And I'm going to talk about a bit about GRESB. And then I'll sort of end with sort of the role of ESD consultants and where we fit in the wider scheme of things. So just as a pretty sort of introduction to ESD, I sort of personally see sustainability can be sort of largely loosely clumped into three main categories. So you've got rating tools, compliance, and sustainability reporting. So in terms of the rating tools, a lot of the participants here, attendees here tonight are from the Australian market, and you would know sort of a lot of these tools, pretty familiar with the projects that you do. So there's Green Star, NABERS, well, and there's also BESS and Environment Development Tool, which is more, it's sort of like Green Star, but it's a different sort of organization that runs it. We've also got compliance in the middle of the middle category there. So that's the regulatory type requirements. So you've got council requirements from set by for example, the Melbourne City Council. You've got sustainability management plans, stormwater requirements, ASICs or basics, which is New South Wales concepts. Section J and JV3, which I'll go into a bit more detail later on tonight. So that's to do with the National Construction Code. And then we've got NATAs, which is more towards the residential side, apartments or housing, that kind of thing. And then on the third category that I have there is the sustainability reporting, which is GRESB and GRI and RI. So what these are is sort of big organizations trying to show their transparency in terms of their sustainability or ESG related actions, policies and actions. So it's about talking about what they've done in the ESG, so environmental, social and governance space in the report, whether that's in the annual report, sustainable report. So that's what I see as sustainable reporting. I'll talk a little bit about GRESB at the end, so more to come on that later on. So just continue on with the ESD overview. Sustainability consultants have a wide range of topics that we consider in the design. So energy is obviously what I'll be talking about today, but there's also water, waste materials, indoor air quality, health and well-being management, etc. So, for example, if we talk about Green Star, there's a lot of requirements that deal with all these other categories aside on top of energy requirements. There's also National Construction Code, NCC, which we sustainability consultants carry out very regularly, commonly. So that's sort of to do with how to design for insulation on the walls and roof and floor, and the glazing sort of window performances of buildings. And then we've got Green Star, NABERS, and GRESB. As I mentioned, I'll talk about that a bit more. So now I'll start talking about sort of the design of building, the start of the process, and in terms of putting pen to paper, what we do to consider energy efficiency right at the beginning of a design process. So the National Construction Code, if you're a service engineer listening to this presentation, you would know what NCC is. So that's sort of the standard that we all design our buildings to. Of interest to me in particular is the Section J part of the NCC code. So that's to deal with energy efficiency and reduction of greenhouse gas principles. So it's looking at how you can design using sort of passive principles to reduce the energy requirement or energy demand of the building itself. So there's two parts to the Section J code. There's a deemed to satisfy, which is the J1 and J3, it's building fabric and building ceiling. And then there's the JV3, which is the modeling. So I'll be going explaining the concepts of these two in a bit more detail. So first of all, it's the deemed to satisfy. So this is the what we call the prescriptive requirements of Section J. So these are the sort of the minimum standards for insulation for walls and roofs and flooring. So when we talk about Section J, we're talking about the thermal envelope of the building. So if you've got 3 or 4 story high building, you're talking about what you need to wrap the building around to keep the heat in, for instance. So we're focusing on the thermal envelope of the building, and so that includes the walls and also the glazing as well. So in terms of insulation, we talk about the R value of the walls, roof and floors. So that's just how much insulation you put into, say, the roofing or the walls. In terms of glazing, we talk about, we specify thermal performance of glazing with the UVAL and SHGC. So that's sort of the heat transfer of a window pane, or the solar heat gain of a window pane. So in sort of simple terms, that's talking about whether a glass is single glaze or double glaze, and that's the U value. SHGC is how tinted a window is. So if you've got a building that's essentially a glass box, then you'd imagine that the performance of that building is really focused on the glass performance itself, because of the fact that the glass is making up the thermal envelope. So how we design to the deemed to satisfy Section J prescriptive method is through a facade calculator. So I've included a snapshot of that here. So there's been a change in the code, as many of you would know, the NCC 2016 towards the NCC 2019. So 2019 comes into effect officially next week, I guess, yeah, in May. And that's using a new set of criteria that's quite different to the NCC 2016, which is what we've been using for the past couple of years. So in principle, it's still the same. We're still focusing on the thermal envelope and how to wrap the building up with insulation or high performance glass. In 2019, there's a bit of changes in how we calculate the thermal envelope properties. So this is just showing you a snapshot of what we do basically on a daily basis. We have to measure how much glass is being used in a building. So we work out what the glazing to wall ratio is, and then just to balance up how much insulation you need, what the thermal values will be for the glass, whether you can get away with sort of single glaze or not. So this is basically the prescriptive method, and it's basically a very lots of inputs into an Excel sheet that you try to design a building to. So that's deemed to satisfy, Section J. The next section I want to talk about is the JV3, which is the modeling aspects of Section J. So I went through sort of the prescriptive method, so deemed to satisfy. If for some reason the building can't meet those prescriptive methods, then you need to do a performance solution, which is the JV3, the modeling pathway. So when you talk about JV3, you're essentially building up the geometry, building the building fabric in a 3D model, and the software we use at ERBIS is IES, which is a very commonly used tool. And what you do is, build it up in build up all the walls and glazing, and you take into account all the shading of the surrounding buildings as well. So I'm going to have some animations in the next few slides to show you what the model looks like in action. But basically the point of JV3 is to minimize, to compare the energy consumption between the reference building and the proposed building. So what that means is the reference building, you've got it's based on the prescriptive method, so it's deemed to satisfy. So the reference building is, if you designed it to the prescriptive method, the reference building, the deemed to satisfied method, then you're going to get X number of, energy consumption of greenhouse gas, depending on which code you're using. In the proposed building, that's when you change the prescriptive elements. So you want to, maybe the client is interested in putting in single glaze windows in all of the north facade, for example. But in the prescriptive method, you had to do double glaze. So we're sort of stepping away from the requirements of the prescriptive method. So once you build up two models, one with what the client wants and one with based on the prescriptive method, you get two sets of energy consumption values, and that's where you compare them. And if your consumption value is better, the proposed model, if the consumption value in the proposed model is better than the reference model, then your model is compliant. So again, it's all about compliance. And that's usually, the JV3 method is usually taken for more, I'd say, more complicated buildings with lots of glass, lots of odd shapes, curves. If it's usually taken, say, if an architect or if the owner has a particular aesthetic feel or aesthetic desire to the building, so maybe they want it to be all clear glass, whereas in the prescriptive method, they need a tinted glass, but they want a very clear glass, so they need to do that through the JV3 model. As you can guess, because 3D model, it takes a bit of time to build up. So for the next few slides, I'm going to show you a few animation to show you what the model is like. So this is a JV3 model that ESD undertook, and this is a surf clubhouse. So basically what we were asked to do is the reason why this was a bit of a challenging project, because on one side, so on this sort of southern end, that's all existing clubhouse, whereas on sort of the northern end here, it's all new. So we had to make basically the whole building comply. So we had to make the existing part, which is a very old, it was constructed a very long time ago, and there was no insulation in the walls, no insulation in the roof, and the glass were all just paper thin. So we had to work out a design solution that would make this whole building comply with the NCC codes of today. So basically it was trying to balance out designing a very high standard on this side to compensate for any more traditional design on the south side. So this animation just shows the sun going around from east to west. So that's the sun up there. Hopefully the animation is not too lag on your side. This just shows a walkthrough of the building. And you can see that we've built in, there's like a little carport there. That's what that hole is. I'll just play it again one more time so you can have a look. So you've got the glass, we've built in all the glass in. The roof is not a flat shape, so there's actually a bit of irregularity in this building. And you can see, you can see that the model does simulate like shadows as well. You can see all the rooms. They've got some glass up the top here as well. So so basically that's the geometry of the JV3. So once we build that up, we have to basically assign energy operational profiles to the hang on. And energy profiles to the different zones so that we can start simulating what the energy consumption is for the building. So the next slide. So this is another building that we modeled, and this, you can sort of see this is a commercial building. So basically this building here, that's the building that we're modeling. All the pink part is actually neighboring buildings. So this is located right in the center of the city. So it's overshadowed by a lot of these other buildings adjacent to it. So there was, at one point, they were even considering putting PV cells on the roof, but after putting the adjacent buildings in, it didn't seem like it warranted PV panels, like it wasn't going to get a lot of sun throughout the year. So I'll just play this animation. This shows the summer sun. So you can see that the sun's quite high up. Obviously, so north is on the left of the slide. So the sun obviously doesn't go up to sort of 90 degrees on top of the building because we're in Australia. This is in Melbourne, so the sun is always going to be a little bit on an angle. So that's the summer sun. If we go to the next slide, this slide shows the winter sun. So IES is able to see, it generates sort of the performance all year round. So you can see here that the sun is much lower in the horizon than when it was up in the summer. So this building throughout the year does not get a lot of sun on the roof, maybe just only on the sort of afternoon side. But yeah, so that little sort of building, commercial building there, is overshadowed by the surrounding buildings. So that's this winter sun, and I've just got one more animation there, just comparing the sun at noon throughout the year. So this is at noon, and you can see that it goes up and down. So obviously when it's down, that's during the winter, and when it goes back up, that's during summer. So yeah, so all of that is part of the input to generating or estimating the energy generation of that building. And on a side note, you can also run thermal comfort models, so PMV, so that's predicted mean vote. PMV analysis, you can do daylight analysis, so all of that glare analysis, so you can do all of that in the geometry, based on the geometry we've been built, and it's just about putting in different settings in the IES model to get the results that you want. Oops. So just to round out the section J part of my presentation, so in the section J of the NCC code, what we're trying to do is advise on values, mainly the insulation of the building fabric and the windows as well, so even doors, so anything that's glazed. So we want to assess what the design performance is for the building fabric, and how we can, in doing that, to minimize the energy consumption of the building. So if we're doing JV3 modeling, that's sort of a way to, what do you call it, compromise, offset between windows and insulation. So if there's a physical constraint of an existing building, for example, if the walls are really thin and you can't put the insulation required from what the DTS or prescriptive method is saying, then you go into JV3. You try to performance solution out the required required insulation into that space. So it's about optimizing the building fabric. It's also about advising on the solar passive design in the early stage of development. So the earlier that a sustainability consultant is engaged in a project, the better it is. So oftentimes we we get engaged a bit too late, so we have to work with the design, the facade design that's already been set. So they might have, you know, full-blown curtain wall windows on the, you know, north or east or west facade with no shading. Then that makes it very hard for us to give them a design solution that they like. If we are engaged a bit earlier, then we can tell them, you know, the curtain wall or, you know, the big glass on your north facade is not going to work. If you really want it, then we can advise you to add a bit of shading or a bit of fins to get the design that you like. So yeah, so it's pretty important that we advocate to be on a design team as early as possible. There's also uniform glazing opportunities. So JV3 allows us to specify uniform glazing for all facades. So that means having the same, you know, single glaze or double glaze, or having the same type of tint or color on all sides, whereas that's pretty difficult for a prescriptive method. Minimize upgrade work to retain facades, so physical constraints. So yeah, so I just mentioned that before. So basically, if you've got some physical constraints, some heritage elements, for example, or the site is very limited in size, they need really thin walls, or maybe they want a particular type of glass because of whatever reasons, council requirements, then modeling would be the solution to find a design outcome for them. Cost awareness of proposed building and fabric systems. So again, this is sort of like ties back to the first point of optimizing building fabric. So in a prescriptive method, you might have the calculator might recommend very, very high performing glass. So even triple glazed glass. Sometimes there's just too much window on the facade that the calculator says you need a very, very low U value, which is maybe triple glaze system of argon gas filled in the gaps. So that's very expensive. Family of broken windows. So if you want to save a bit of costs for the end client, you might want to, you know, undertake a JV3 to design that out. Design that window specification out by having more insulation on the roof, on the floors, or walls, or anywhere where you can put it. So that's section J, and that's sort of largely designing for having an efficient building fabric to minimize heat loss or heat gain. So obviously, if you've got a good building fabric, a good thermal envelope, then you minimize the need for air conditioning in the summer or heating during the winter. So that's sort of the principles of the National Code and Section J. So now I'll move on to Green Star. So I think a lot of you would have heard of what Green Star is. So Green Star is a design guideline for the design team. So we're talking about services, architects, structural engineers, civil engineers, landscape contractors, building owner, developers, so on and so forth. So it's basically involving everyone in the design team, and it's a voluntary guideline, so it's not compulsory. It's basically it's a star rating system. So depending on how much sustainability requirements you incorporate into a building, you get rated and you get given a star rating. So why do developments like to go for a Green Star rating if it's not compulsory? So there's a lot of factors involved in that. So it could be market driven. So you know, all the buildings that are being built in the city right now, whether it's Sydney or Melbourne or other major cities, I'd say 90% of the tall towers, commercial towers at the least, would have some kind of Green Star rating or neighbors rating, even WELL rating. And that's just a sort of like you can say it's like a market driven trend, and which sort of links onto maybe the policies of the sort of the organization developers. So like, for example, if we take CIBSE property, for example, so that's one of the clients that we deal with, they have a policy there that, you know, all the new buildings must be a certain Green Star rating. So it's, although it's not compulsory, it's not policed, it's something that they want to strive for and become sort of a market leader in sustainability in their assets, in their portfolio of assets. It can also be, for example, maybe green bonds. There's a lot of finance mechanism exists out there where it's tied to a lot of green or sustainability credentials. So if you've got buildings that say have a green bond sort of funding or some other related equivalent mechanism, they might require buildings to report to them, every year or just periodically to say that you are meeting these energy requirements, or you are meeting, your portfolio is having this kind of star rating, and that you're maintaining it. So that's probably some of the reasons why Green Star is being used. There are 4 different kinds of tools. So we've got the communities, design and as-built, interiors, and also the performance. So usually when clients come to us and say they want a Green Star rating, usually it's the design and as-built. So that's the second one. Design and as-built is for the base building, the core and shell. I'd say the second most popular one's probably the interior. So that's related to fit out. But by far the most popular one's probably the design and as-built. Councils use Green Star as a benchmark mechanism as well. So, for example, the Melbourne City Council, they have in their planning scheme that any building over a certain size needs to be designed to a 5-star Green Star building. So we need to prove to the council at town planning that there is a design potential of the building to reach 5-star Green Star. So I'll talk into a little bit more detail and then expand on the energy parts of Green Star in the next few slides. So communities and performance are 2 other tools. Communities is more for precinct scale ratings. So if you've got a whole block of schools or residential buildings or commercial buildings, you might want to rate the entire area for the Green Star, for Green Star rated area, sort of precincts. The one on the end there, performance, that's more a operational Green Star rating. So when I say operational, it means they need to recertify periodically every year or so. So whereas all the other ones, the first 3, they are just one-off certificates. So you can get a certificate at the end of PC or post-construction. After construction, that's when you get the rating, and that rating lasts forever. So that's Green Star as an intro. In terms of the star rating, so I mentioned before, there are different levels of star rating. So in terms of the most common one, design as built, you can get a 4-star, 5-star, or 6-star star rating. So in terms of points, it's based on a point system. So there's roughly around 100 points to obtain in the Green Star scorecard. So to get those 100 points, you need to target particular requirements. So if you've got 5-star, you need, if you're aiming for 5-star, you need 60 points out of the rough 100 points. And for 6-star Green Star, you need 75 points. So what we usually do at the start of the project is to come up with a scorecard with a bit of a buffer, usually about 10%, in case there are any requirements that drop off. Some furniture can't be, maybe some furniture, there's some lead time that can't be procured on time, so that they need to drop that point off, for example. So there's usually a bit of a buffer that we design into to reach that 5-star, 6-star level. These are the main categories of Green Star. So you've got management, indoor environment quality, energy, transport, water, materials, land use and ecology, emissions, and innovation. So for the services engineers listening to this presentation, I think a lot of you would be familiar with at least some of these. So, you know, your IEQ, indoor air quality, you've got some acoustics requirements there, or you've got outside air requirements, lighting requirements to do with it ties in with energy as well. In terms of water, your hydraulic engineers, you would have looked at rainwater tanks. Yeah, it's just water reuse. So yeah, so these are the credits that the services engineers will be hopefully very familiar with. But aside from that, there's a whole lot of other requirements that are related to non-services. So it's maybe more architects or more contractors. So for example, for management, there's a credit on the contractors having a environmental management system, EMS. So they need to implement that, how to manage the site and how to get the subcontractors to adhere to the EMS guidelines as well. There's also credits on paints, which is more architectural. So when they specify the paints to go on the walls, the sustainability consultants have to review their, you know, architectural schedules to make sure the paints have the required thresholds that meet Green Star requirements. For transport, that's to do with end of trip facilities, so having enough bike parks in a new building, enough showers and lockers. There's also for land use and ecology, that's some requirements there for the landscape architect, for example. If you've got a green space in your development, then we try to push for using species that are vegetation, like the plant species, to be sort of drought tolerant, or encouraging indigenous or native species to be planted back into the site to increase the ecological value of the land. And there's lots of requirements for you know, reuse. Maybe if you're reusing furniture, if you're doing a fit out and you are moving from one building to another, then we try to get them to reuse the chairs or the tables, and because Green Star recognizes points for that. Yeah, so that's basically the categories in a nutshell for Green Star. In terms of energy, there's a few that sort of links with energy, but the main credit for in the Green Star manual is this one, greenhouse gas emissions. So the intent of the credit is to reduce greenhouse gas emissions, reduce energy demand, and ultimately flows on to reducing the operational costs for building owners and occupants. So there's a bit of focus on a few areas so that you can see that there's different pathways. So credit 15, there's 15A, 15B, all the way to E. Usually we, depending on the building, which one you want to target, but there's 15A is the prescriptive one. So that's usually we've got, you know, you have to increase the building fabric from section J, which is what we talked about before, increase the building fabric of section J by, you know, 15, 10%, and the insulation by 15 or 10%. There's also requirements on the HVAC system. So having a high COP value for some of the systems there. You want your pumps and fans to be very efficient. Also the lighting, there's some requirements on lighting. So having the electrical engineer to design to a percentage below the NCC requirements. And there's also sort of a push towards renewables as well. So we've got peak electricity demand is another credit that's I haven't listed here, but it sort of encourages the use of PV panels or solar panels on a roof to meet a particular demand consumption threshold. So it sort of, at the peak electricity usage, the building is able to lean on the solar panels to get the energy from, to reduce the reliance on the grid. So so renewables is definitely a consideration. Domestic hot water systems are a consideration. So, you know, whether there's heat pumps or gas, there's some requirements in there. So that's basically the Green Star requirement for Green Star. So far what we've talked about focuses on the design of the building. So we've got the Section J NCC requirements, which is the regulatory requirements. That's absolutely compulsory. It's mandatory, and then it gives you sort of a baseline of the building fabric, so the walls and the glazing. Green Star is sort of one step further than that. It sort of builds on the fundamentals, that the baseline set by the NCC code, and builds on how to improve on that baseline with this credit, for instance, having a percentage better performing than the NCC code. You can also do modeling. So 15 credit 15E at the bottom there, that's to do with modeling. So that's similar to what we talked about in the Section J, where you build up a model in IES and then you have to reduce the energy consumption or the greenhouse gas emissions of the proposed building. So that's the actual design building compared to a base case. So if the base case energy consumption is here, at the bottom, and then you are reducing energy consumption of the building by so and so measures, efficient lighting systems or HVAC systems or really good glass. The more points you get, so there's a sliding scale of how much Green Star points you can get, depending on how much energy consumption you can reduce relative to the baseline. So that's Green Star, and that's sort of the design aspects of a building and how it relates to energy. I will go through operations and just introduce you to the concept of neighbors. Hopefully, I'm sure a lot of you would have heard of it or familiar with the concept. So let's just pretend we've finished building the building now. It's NCC, National Code, Construction Code compliant. It's Green Star rated. So now we are looking at the operational of the building. So it's up and running and there's people working in the building or living in it. So Neighbors is another rating system similar to Green Star, but it's more energy focused. It's energy focused. So it's an annual rating system. Unlike Green Star, for Neighbors you need to get recertified every year, and you can rate it for base building, tenants, so like fit out, or a whole building. And it's also mandatory for buildings, commercial buildings, which are more than 1,000 square meters if they want to lease it out. So Neighbors also covers energy, also covers water, waste, and indoor environment. Usually when a client comes and says they want a Neighbors rating, they're usually talking about energy. Sometimes they also want a water rating, but yeah, Neighbors also rates the other aspects of waste and indoor environment as well. I'll be talking mostly about energy. So it's most common for office buildings, but as I said, I think, yeah, you can use it on fit outs, apartments, shopping centers, data centers, and hotels. The star rating is similar to Green Star. You start from 1 star all the way to 6 stars, 6 stars being the maximum. It's based on a benchmarking system. So what we do to get the rating is you get the energy consumption bills of a building, and then you basically say, okay, you've used X amount of energy, your building is this size, and you've got this many people in it, and it's sort of benchmark against other similar buildings, which is how you get your Neighbors rating. So so that's done usually about 12 to 15 months after a building is operational. And the reason why it's 12 to 15 months is because you need 1 year's worth of energy bills to get your Neighbors rating. So what we usually ask clients to do is to maybe do a monitoring exercise for the building as well. So when when a building is finished, there's usually 1 year's worth of building tuning or defects liability during that 1 year. And that's when we come in and monitor the building for them. So what we do is tap into the meters, the BMS system, and assess or sort of extract out the energy consumption data. We recommend 15 months usually, because the first 3 months are usually up and down. They're still tuning the system. Something might not be working. So usually 3 months, from past experience, it's usually a bit, you get lots and lots of energy consumption, or you get like no energy consumption for some equipment. So usually the first 3 months is not very accurate. So after those 3 months, that's when you start building up your 12 months of data. And that's when we get involved with building tuning meetings. So that 12 months of monitoring also is a good idea, because it goes through the seasonal cyclical environment properties that are being experienced by the building. So we'll go through the trough of winter or the heart of the summer. You're able to see how the chillers are working, how the boilers are working, whether if you've got automation of the windows, whether they're working. So it's a good idea to do that every month for that 15-month period to get that seasonal trend. I've just got some graphs here quickly to show you. Here's an example. Like if you've got a client who's interested in looking at how the performance or the assets are performing. Say, for example, you've got a client here. You've got five assets, 5 buildings, and they want to see how much energy they're doing. You can sort of plot the graphs, normalize it. So on the axis, vertical axis here, you've got your assets and then a portfolio average. And then on the bottom axis, on the horizontal axis, you've got the greenhouse gas emissions or the electricity consumption. So if a client wants to look at how well all the assets are performing in terms of the neighbors' benchmarks, you can do that with the sort of the graph on the right. I've got the little bands there. They're sort of dummy bands, not real, but like you can say if asset 4 and 3 are aiming for, I don't know, 5-star neighbors, then maybe that's where the band is, and it would change depending on what state you're in. So asset 4 and 3 in this case is overperforming, so they're actually not getting the 5-star neighbors. So a graph like this is a good snapshot for the client to show them that you're having excessive consumption. So that's the bar charts as a snapshot. Here's the seasonal trends I was talking about. You've got asset 1, 2, and 3. Again, these are sort of like just dummy graphs. On the vertical axis there, you've got consumption. And then on the bottom there, you've got the months. So what you do is, you can see that, in the winter, this might be chiller usage, for example. It can also be something else. So, maybe it's a fan, I don't know. So you've got, you want to wonder why asset 1 is performing higher than asset 2 and 3. Why is there like a little hump in asset 1 graph and April? Maybe they had maintenance works. So things like that is very useful for building tuning. And even after building tuning, if the asset is 2 or 3 years old, hopefully the facilities manager of the buildings are doing diagnostics like this, just to see the trends and to be able to pinpoint what's happening in the buildings. So that's operational, the operational side of energy. So I've taken you through the journey of design and then the operation. And now I'll just quickly sort of finish up with a bit of where energy fits in with sort of, if you step back in the bigger picture of things, why big companies are interested in energy efficiency, apart from saving the world and climate change. So that's very obvious. But in terms of GRESB, Global Real Estate Sustainability Benchmark, that's an upcoming trend that a lot of big companies or big developers are signing up to. So you've got the likes of CIBSE, ISPT, your lend leases, they are signing up to do a yearly annual survey of the ESG performance. So that's environmental, social, and governance. So it's basically a yearly survey that assesses whether they've got policies to govern ESG, and also whether they've got implementation or actual actions that are driving these ESG initiatives. So the target audience is investors. So basically, if you've got a big investor with a lot of money, they want to invest a lot of money into a green portfolio, they might look at the GRES results and see which of your CIBSEs or which your land leases are performing the most green or the most sustainable in the operations, and they might want to invest in that company if they want. So it's the target audience is investors, but it's also used as a way to sort of celebrate the fact that this company is doing a lot of sustainability related initiatives in the building and in the asset. So the reason why I mentioned this in this presentation is because performance indicators is 25% of the overall score. So because that benchmark, GRES is benchmarked against other sort of national Australia and New Zealand, but it's also the world as well. So for example, CIBSE Property, one of our clients, they scored very highly, third, I imagine, I think, yeah, third in the world and second in the world, second in Australia. So they means that they are performing really well in management, policy disclosure, risk and opportunities, all these other categories. But the one that's that really is a focus is performance indicators. So that's looking at the energy consumption, energy performance of the entire asset. So it's very important for them. They've got a vested interest to improve the energy efficiency year by year, because you get more points if you can show that you've reduced your energy consumption compared to last year. So they're always looking at ways to increase your energy efficiency, whether that's, improving the BMS system of a building, swapping out old lights for LED lights, automation, replacing old boilers, old chillers, fine-tuning the controls of a building. So they're always looking at ways to increase the energy efficiency of a building. So that's GRES, and where energy fits into this wider GRES sort of framework. And finally, I'll just share with you just a last slide of the role of ESD or sustainability engineers and where we fit in. So we would like to fit in right at the start at the concept design, maybe even before before concept design, so off the page. So the reason being is because we want to be there to give very high level preliminary advice on if you're talking about glazing extents, like how much glazing you need to get the desired aesthetic feel you want, or if you want that amount of glazing, you need shade somewhere. So we want to be there advising as early as possible. If we're talking about Green Star, we want to be there to create a scorecard for you to start incorporating initiatives into design. So the earlier the requirements are communicated to design teams, so the service guys, your mech guys, hydraulics and electrical, the earlier that they know that they need to put in 50% extra outside air in, or they need like zoning, they need lighting zoning to be of a particular area. The earlier they know, the better it is that they can incorporate into the design documentation. Same for well, if you're designing for well, for example. I didn't really talk about that because that's not less of an energy topic, but things like that we want to be there as early as possible. And then you got SD and DD, which is your schematic design and detailed design, and that's coordination with the design team, reviewing the design, making sure the architects are specifying the paints correctly, the timber is being bought from the correct suppliers with low formaldehyde, that kind of thing. Tender documentation, so that's where we write our specs to make sure that contractors know what they have to do. And then the actual construction, that's probably a high risk sort of segment for Green Star. And that's when you have to make sure that contractors understand what the intents of each of the requirements are and what they have to do to meet the intent. So one of the Green Star requirements is waste, for example. So they have to make sure that they're segregating the waste correctly, that enough percentage are being diverted from landfill. So they need to understand that right from day one, because it starts from demolition. So that's construction, and post-construction, sort of compiling documentation for Green Star, for neighbours and whatnot. Yeah, so that's basically, we are involved throughout the entire project, especially for Green Star. We are right there at the end during the post-construction. We are the ones that annoy the other services and design team that we're chasing for documentation. So that's when the client gets their 5-star, 6-star Green Star, once we can prove that we've done everything. And that's it for me. That's the end of my presentation. Hope you've enjoyed it and got something out of it. Basically, the focus was on energy, but there's a lot more to sustainability than just energy, which hopefully I've touched on a bit. But ultimately, the focus was, I tried to give a sort of brief overview, high-level snapshot of what we do to design for energy considerations throughout the process. Thank you.
Fantastic. Thanks, Jane. That was a wonderful presentation, and thank you so much for giving us that overview of an ESD engineer. Now we have got 13 questions here, but they're mainly from 2 participants. So I'm just looking at Sean's asked about, or thanking you for being the first presenter for CIBSE Victoria. But do you have any metrics on the payback time for implementing sustainability concepts into buildings?
Yeah, I mean, like, it probably depends on what you're talking about, maybe PV panels or rainwater tanks, for example. So yeah, so there's a lot of research done on the payback of PV panels. I think at the moment it's a couple of years. Don't have the number off the top of my head, but definitely it does depend on, how much PV panels you've got, if we're talking about PV panels, the orientation, where you are, is your building shaded? So there's a lot of assessment done on that. So electrical engineers, for example, they are able to give you a rough payback, and for the client especially, on whether they want to invest in something. In terms of other initiatives, so we've got we're currently engaged in a project for a school where we're doing a feasibility study on all sorts of things, so not just PV. Maybe we're talking about solar farms or wetlands, passive design principles, things like that. In those cases, the payback might not be monetary, so you might get a payback, 10 or 20 years, but there's also we're also talking about the payback in terms of educational value for the occupants. So if you're talking about in the school setting, what's the if you get a black water treatment or grey water treatment, things like that. The social payback, as you said, the social side of things is, teaching the next generation of students on what sustainability is and how they can contribute in a wider world, and potentially if it's a area they're interested in, maybe that's something they want to pursue in. So yeah, so I guess there's definitely paybacks can be assessed, but hopefully the topic is the conversation not just about monetary, but also about the other aspects of environmental payback and the social payback as well.
Okay. We've got a couple of questions there on building air tightness testing, and is this something you'd recommend to clients as a sustainability consultant?
Yeah, If it's done well, yes. In principle, it's a very good idea because basically it links in with sort of the J3, section J3, which is building sealing. So that's to do with sealing up the cracks and finding all the holes and putting a membrane on to reduce the leakage. It's also sort of a principle for passive house design as well. So building air tightness is definitely a very, very well-founded concept in that you want to limit the amount of air or energy consumption leaking out of the building. So yes, I would recommend it, but only if it's done well and if you've got a client who is sort of or a contractor who can carry out this works, because it's not as straightforward. In terms of the art, and you have to get also an architect who knows how to detail air tightness in it as well. So I really liked to see air tightness being more prominent in Australia. I can't say, like in the past few years, I've only done a handful of developments with air tightness as part of their requirements, or it's part of the Green Star requirement, for example. So it's definitely something that it should be pushed more often, but and it's a good idea as well, but it's not done sort of commonly in Australia.
Okay, fantastic. There's a question here about, we've got suddenly getting a flood of questions coming in, but unfortunately we've only got enough time to cover a few. So question here is saying if you could shed some light regarding the updating of the climate files within NatHERS. I don't think is this something you'd cover? Previously, this has been many errors. Also wondering if J3 or NatHERS would adopt passive housing standards in the near future.
Okay, that's interesting. I think that's a bit more technical in terms of the climate files, because that sounds like a specific operational input into the modelling aspect of NatHERS. So happy to if you can give me a bit more detail on what the question is, or happy to contact you.
Might have to do that offline, I think. Yeah.
Yeah.
So you mentioned in your presentation that CIBSE and ISPT, etc., they've set net zero carbon targets for their portfolios. Would you be able to give a brief overview of how you advise clients on how to meet these zero carbon targets?
Yep. So I think you see that a lot more clients and not more developers now would be setting net zero targets, because I'm sure a lot of you might have heard the Green Star guidelines are being refreshed and updated. So at the moment we're still using V1.2, V1.3. And hopefully that sounds familiar, but that's the current tool that we're using. The new tool that's going to come in, I think it's called New Buildings. They've got a name for it. That's coming in very soon. There's going to be a transition period, but basically to get your 6-star Green Star, you're going to have to be a net zero building. So to stay on top of that, as I sort of mentioned before, that market-driven, the market-driven desire to have Green Star to be the top of the pack. Lots of clients are going to be asking, how do we get that 6-star Green Star? What does it mean to be net zero? And basically it's a combination of looking at the energy demand and also where the energy comes from. So in terms of the energy demand, you want to reduce the energy demand and hence consumption in, what I talked about, the fabric or passive house related sort of requirements, principles, in that you want to, if you can design a building with a thermal envelope that's basically very airtight, which we talked about, and also like high insulation, really high performance glass, your electricity demand would be decreased drastically. So you'd see that your HVAC, your air conditioning, your heating requirements are reduced. So that's one side of it in the fact that you're trying to reduce energy consumption on demand. The other balance to the equation is the energy source, or where the energy comes from. So the most obvious one would be solar PV panels. So if you can integrate that into a building, if you've got enough roof space, then you can sort of get a lot of your energy consumption, electricity needs from there. There's also, other aspects. Geothermal is one that's been talked about a lot. Not necessarily generating energy, but using that geothermal system to sort of borrow heat from the ground. So heating and cooling loops on the ground, doing that to offset the load on your HVAC system. So it's sort of coming up with ways to balance the two, and hopefully as we go more towards sort of as our electricity is being made from more and more like solar farms and stuff, and less on fossil fuels, hopefully the net zero would be pushed not just on the building scale, but also sort of as a whole as Australia, if we can move towards decarbonising sort of the country, then that would be the way forward. So it's managing demand and also managing where the energy comes from.
Okay, thanks, Jane. Here's another interesting question. Sean's asked, is the JV3 modelling comparable with the actual building performance? Is there any post-occupancy performance metrics that need to be achieved?
Yep. Thanks, Sean. So it's comparable if it's modelled accurately. So I've done a lot of monitoring in the past where we try to compare it with the actual model. So I'd say it's largely it's a good indicator, but if you're wanting to get exact values, then it's a bit hard, just because in real life, when you start constructing things, it can differ, like it can detract a little bit from what you design, what you documented. So maybe the HVAC system isn't commissioned or isn't tuned or isn't controlled the way that what the engineer had in mind. Maybe the insulation is a little bit different to what the design documentation had documented. So I'd say it's a good indication, but it's not sort of exact value. You won't get it to the dot, to the decimal. But from my past experience, I've done monitoring for base building and fit outs as well. So there was one example where I did monitoring, 15 months of fit out monitoring. They didn't actually have a BMS, so I had to physically go to the fit out, and there was over 6 floors, so I have to climb 6 flights of stairs for every month, so it was good exercise as well. So basically for that particular project, they actually performed exceeded the performance of the model. So what that means is, like, we designed to a 5-star, but 5-star neighbors, but eventually they actually achieved a 5.5-star rating, and that was just because the actual performance differed from the modeling, but in a positive way. So that was a great outcome. And that could be because maybe they didn't turn on the lights as much as we thought they would, or maybe there was less occupants or less computers than we modeled. In another example, I monitored a base building as well, and that had an opposite effect. So they were actually underperforming. So they produced more energy than what the model was saying. And so we had to go back and basically find out why, whether it's the actual building or whether there was something wrong with the model. So I think in the end we found out that there was some staging problem. I think it was with the boilers. I think it was boilers where they had a few, and then they all turned on at the same time, whereas it was only supposed to be one of them turned on at this, when it's this load, and then the other one comes on. And then so it's all about tweaking it. So in that sense, the energy performance, the actual energy performance is not going to match, especially at the start of the building tuning stage, which is why I said we want to sort of tune the 15 months. So I'd say, I mean, Tony, I think you'd have a lot to say about commissioning, but I think in terms of we want to marry up the actual consumption and the modeling at the end of the day to get that 5-star green 5-star neighbors, for example. So we want to minimize the gap between them. But yeah, it's very hard to get exact energy consumption values from a Green Star model or neighbors model or JV3 model. I think I can't hear you, Tony.
Thanks, Jane. I was wondering what sort of challenges you're seeing with shifting the culture of full height glazing in buildings, particularly around the new NCC 2019 requirements with architects. So that's from Aaron.
Okay, thanks, Aaron. Very challenging. I think architects always want a very they're very visionary in terms of what they want for the building to look like and what the clients want. So I'd say full glass, full height glass, curtain walls, they are very commonly asked for like in terms of architects, that's what they want. So we just have to do what we can to accommodate what they want. So usually if they've got a lot of glass, especially in the new NCC code, it would definitely have to be sort of like a modeling approach, JV3 modeling approach to get what they want, because then probably not going to meet the prescriptive method in Section J. So I think Aaron sort of touched on the fact that the new NCC 2019, there's a difference there between 2019 and 16. So the old code is 16. It's a bit more stringent now in the new code. So it's basically if you've got the same, it's especially worse for full sort of a glass box if you've got lots of glass. I mean, I can't say worse because it's actually better for the energy consumption wise and greenhouse gas. But it's a bit more of a headache when you're trying to find the design solution that the architects want and the client wants. So yeah, so it's definitely it's made it a bit more challenging to give what they want. But usually, if it's a JV3 solution, we have often been able to find an optimized solution for them. If they want a curtain wall, surely they'd have to. They're usually willing to offset it with thicker walls, more insulation, or a thicker roof. Usually, a roof if you've got a lot of roof space, or like a big roof footprint. Then the architects are usually very accommodating in offsetting the glass area with just a bit more insulation elsewhere. So definitely challenging, but nothing that we can't solve. Hang on, I can't hear you again.
Thanks, Jane. That was a fantastic presentation. I'm sure there's some virtual hand clapping about to happen.
I can hear them.
So we ended up getting a lot of questions, but unfortunately time's getting away from us. So yeah, thank you very much. Hopefully we'll make the presentation available to the participants in the webinar. And I'd like to thank all those people who attended our first webinar, because this is our pilot one for CIBSE Victoria. And it's been fantastic, the support we've received. So well done, Jane. That was a fantastic, very informative presentation about an ESD engineer. And thank you very much. And thank you very much for all the people who attended this evening. Thank you.
Thanks, Tony. See you later.
Thanks, Jane. Bye.
Bye. Thanks. I'm still here, but yeah, thanks for everything.